Okay, where are we going? What are we doing? This is cat, right? Meow. Okay. I love looking at the calendar. Obsessed with it. Uh, Yelling at those that did not. That stands for be right back. Okay. I guess people are having some issues computer-wise. But did I? Oh, I'm not presenting either. John S., I just saw that marine symbol as your symbol for Google. Pretty cool. Okay, am I presenting now? Okay, I made a couple mistakes last hour. Wasn't presenting as a blabbering, and then I forgot to hit record for getting records of what we're doing today. So should have done this video last week. Just gonna go off of that and continue. And then hopefully you did do 1 through 9, just the front part of that worksheet. Just want to make a note to self that that's supposed to be finished now after I go through today. So I'm going to go through at least most of the other ones. Some you might still have some problems with on the bottom half of the back page, but the top half is from a picture, what's the equation? And I'm going to show you that today. Another assignment just to add to the fun is probably repetitive, but I felt, we should probably have something going on there. And in today's notes, I am going to bring up-down shifts because they're easy. I don't care what anyone says, they are. If you can take care of all the other stuff. Then if your day is not tomorrow to be in school, you could still do that quiz is. Because there are some questions that incorporate some up-down shifts and what is the range. And it really isn't that hard. So I thought I would do that in the midst of what I had planned today. So here is what I would call the bell work, but we're already about 3 minutes in. So and the third one, we're not going to be able to graph. We just don't have the time. So graph 2 cycles. Don't be one of those buffoons from back in the day. Oh, sure, Mr. Samuelis, here's a cycle. A bike, and then here's another cycle. So if you do that, it's an old joke, and it's not funny anymore. Okay, anyway, I've had that on tests. Sometimes teaching can be quite comical. Anywho, we should know right off the bat when we're looking at this picture that this is a flipped cosine. So in our brain, this is a cosine kid. Yeah. But it's not that. It's upside down. And this is what our picture should look like when we start marking up some important values on our x-axis. And y-axis, of course. And then one more thing. It's kind of a jerky thing for a teacher to mark you wrong for this. But technically, amplitude is a distance. So it should always be expressed as a positive. All right, and I think I did say that last week, marked it appropriately for all the questions that we had, always threw a positive number for amplitude. Okay, so just be careful on that. And then from the video last week, let me hide these 2 things that are in the way. All babies are compared to the parents. The parents period is 2 pi, just what we discovered in class, that extrapolation, love that word, of why the pictures look like they look like. But then we're going to only get those 5 critical values starting with the y-axis. So knowing what you know from last week, if you watched the video, and if you didn't, that's how I feel about you. I'm getting tired of students making excuses for not getting work done. We're all in this together. We all can get our stuff done. I kept the video short, trying to be nice, make sure it's all doable and possible. And really shortening things up to the brass tacks. So this is not 2 pi. This is now 2 pi over 5. And then graphing 2 cycles or 2 periods, it's really not hard. It's a cut and paste. All you have to do is flip to the other side of the origin. Hopefully that's about the same distance. Looks like that one's a little bit farther on the left, but no big deal. And then all it is fractions. This is not calculus. This is not complicated. But for some reason, it seems to be. People just cannot figure out these fractions. I just say they're fractionally challenged. Because all I need is half of 2 pi over 5. See, what we have to do is cut the period into fourths. So that's what ends up happening. And if you really wanted to, this is going to take longer. But this is the fourth of the period value. This is the half of the period value. And this is 3/4 of the period. And if you wanted to physically multiply by those fractions off to the side, fine. It's going to take you longer, though, than what I'm going to do here. Because half of pi over 5, 2 pi over 5 is pi over 5. Now, how do I get this quarter value? Take half of this. First time in the chat. Somebody tell me in 5 seconds, what is half of pi over 5? 4, 3, 2, 1, 0. Nobody knows what half of pi over 5 is? I think 7th hour is on strike. Nice. I should have told you, just do P for pi, but some people, oh, you spelled it right. It's not PIE. You guys are making me hungry. It's PI is the true. So pi over 10. Now watch what I do. Fine, you could take 3/4 of 2 pi over 5 and put that here. But these are all pi over 10 away now. This is all pi over 10, pi over 10, pi over 10, pi over 10. You found the equidistant value to all of these. So watch what I mathematically do, and many of you will be on board with this. 1 pi over 10. Sorry. 2 pi over 10. Wait, hold on. 3 pi over 10. 4 pi over 10. If you don't know 4 pi over 10 equals 2 pi over 5, that's probably part of the problem. Not knowing our fractions really well. So what I do is I keep adding pi over 10 to get the third value. All right, and then I don't have to deal with those fractions, and you can get pretty quick with that. And then all you have to do is cut and paste on the other side. So it's negative pi over 5. Negative, and by the way, these are required. Everything I do in the notes is what you should be writing in your homework and on your questions, and will be assessed that way. So just thinking out loud, students of the past, not marking these x-axis values, this is the hardest part. This is the key, marking these so that we can see them. And then hopefully you have a better graph where they look equidistant. Now it's time to do the amplitude, which is, this is what we can do all the time. That's why on that worksheet, all these pictures are almost going to look identical. But then last week I showed you, what if we put these two graphs on the same plane or same graph, and one's really small and tiny, compared to the other one because the amplitude's so different. Just keep that in mind. Wait for my pen to work. There we go. Now here's the upside down cosine kid. I should erase those fractions there, but I'll leave them, I guess. And then it continues. This pattern continues on the other side. Cosine kid upside down. Cosine kid upside down. Now, finish this question. We're going to write the range down and then just watch my next part. The range. Actually, the domain for cosine and sine is always going to be all real numbers. But the range is confined to -4 to 4, and I think you can see that. And we need brackets because it does hit 4 and -4 as the high and low value. 4 and negative, I did say that respectively correct. So that's all good. All right. Now let's pretend, do not write this down. Let's pretend I added a +3 on the outside, or it could say 3 plus or 3 minus 4. This 3 is actually an up-down shift. It's a D value, your classical D value from like parent functions. When you just add a number on the outside of the function, it moves it up or down. So do know the difference between this times and this +3. That means up or down. In this case, it means up. This is all that would happen. You would take this picture that you graphed, or you'd wait and understand, okay, it's not from 4 to -4. It gets moved up 3, and now the graph would be from -1 to 7. So I'll show you a little bit more tomorrow in class if you're a tomorrow person, because we're going to do both up-down shifts and then right-left shifts. Right-left shifts are tough. That's why I'm not doing them right now. So all it would do, it would change the range and then change, where the graph is actually at. So I do want you to make a note to self. I didn't want you to change this question I wanted you to watch that and show you how easy an up-down shift is, because it really is. Trying to get to the point where it goes, there we go. Nice. Okay, so back to its original. All right, and then because of time, I'm gonna do this one fully, but then the next one we'll just mark the parts and not have a chance to graph it. I mean, I should have said range on the second one last hour, I didn't. Okay, so first thing you should probably assess is what does it look like, and it's sine. So we're gonna have a bowl and a bowl. Okay, that's what sine looks like. Cosine kids like this, sine is bowl, bowl, right? I don't know how that looks to you. I don't know if I'm reversed or mirrored. Not that you're even looking at me though. And then the amplitude is just a half. I mean, think about that graph compared to this one. Here's a half. So this little sine curve would be like this, it'd only go this high. All right, so that's why it's kind of trying to do, like comparing these two graphs. The way you see the period, this graph would be so weird compared to that blue one that we have over here if we had to graph them together. 2 pi over a third. Not teaching fractions. Dividing by a third is multiplying by 3. I guess I did just teach fractions. When you divide by 1/3, that's the same as multiplying by 3. So 2 pi times 3 is 6 pi. This one's actually infinitely easier to find our critical values. Maybe I will try to kind of show it as being shorter on the y-axis. And by the way, the range is just -1/2 to 1/2. You could answer that right now. Okay, so we're going to put 6 pi here. We're going to put -6 pi here because it says 2 cycles. Not even going to insult you by asking you this on the thing. Half of 6 pi is 3 pi. This is the halfway of the period. Half of a half is a quarter. I'm going to write this again. This is my mind. Now again, all of these distances are 3 pi over 2, 3 pi over 2, 3 pi over 2, and 3 pi over 2. You just found the quarter value of the period. This is why I do this. 3 pi over 2. Add another 3 pi over 2 to itself, 6 pi over 2. Okay, that's a discount double check. 9 pi over 2. Let me add another 3 pi over 2 and check that this is 12 pi over 2. It is. So when I take half and then another half, then I take that number right here and add it to itself to just check, get this one, and then check. And then I'm good to go. That's as hard as graphing with radians is. Do be honest with yourself. It's just fractions. And I don't know how else we can teach them. I've been trying to leave the calculator away and talk about fractions all year long. In whatever way, shape, or form we need to. They are an important skill in cats. All right, and then here's the sign. Starts at 0, 0, high point 0, low point 0. Bowl, bowl. There's your range from 1/2 to -1/2. We'll reverse that with brackets. And then this does not happen. Sometimes I get students do this. Draw another sine curve like that, just they get messed up there. You can see how that's not right. The smooth continued operation of this, darn it. I don't have a forward button on this computer. I'm sorry, on this program. It continues down and then back up. So that's another copy and paste of this. So just kind of showing you a common error on that. There's 2 cycles, all right? Then this last one, sure, it's an upside down sign if we were going to graph it. Sure, the amplitude is +5. Please don't make that mistake. And then a lot of times when we have sine and cosine, the x-axis represents like time. So that's why we don't really want to see pi sometimes on the x-axis, because we want to see it as in terms of seconds. And usually we want that to be nice whole numbers. This isn't a whole number, though it is a fraction, but the period doesn't always have to have pi in it, right? So the period's 2/3. Half of 2/3 is 1/3. Half of 1/3 is 1/6. And then that's how you'd break down the axis, and there would be no pi on that one. That happens on your worksheet on 1 through 9 as well, whenever this weird pi is inserted into the equation. All right, we're at about 8 minutes. So this is where I want to get to. You can see globally what we have here. We have 3 pictures. So the directions are going to say, from these pictures, find the equation. So I'm going to zoom in on the directions real quick, like super fast. Cramp in my hand. Hopefully we don't have that happen again in 7th hour. All right. So each function graph is in the form y equals a sine bx or y equals a cosine bx. Determine the equation. So really what you need is this over here. What we're doing, we're filling in these blanks. So the first thing you have to determine is, do I have a sine or a cosine? What am I looking at as it starts off? Like starting at the y-axis, what do I see? And then this is going to be easy. This is the amplitude value. So that won't be too hard. The big kicker is, what is b? I lost my pen randomly again. Love when that happens, you know it. So we know this is the b value right here. And b comes from, or this is how we graph this. If you watched the video last week, and if you watched my last 2 examples, notice down in this example, cosine of 5x, the period is 2 pi over 5, right? So just, you know, that's how I broke this down and cut it into fourths. But you should understand that if I'm looking at the picture, I want b. I want what's in the equation to make the period. And if you remember the Get Triggy With It video, we could switch those two. Those can be switched. Those are called means. They can be switched in position. So actually, the b value in the equation can come from 2 pi divided by whatever the period of the graph is. And that's what we're going to do. Okay, so hopefully you wrote that down in our 6 minutes that we have left. Hey, in the chat, real quick, what do you see? Do you see a sine or a cosine? And is it right side up or is it flipped? Because those are the couple things that you should assess. Please answer in 5, 4, 3, 2, 1, go. From 7th hour. I'm not answering anything until somebody answers on your end. Ooh. We get a sine and then a sine flip. Thanks, Jeremy and Adriana, for chiming in. Don't want to agree with someone, and don't feel bad whoever is incorrect, because one of you are. I'll wait for one more person to verify. 7th hour is on strike. They must be. Thanks, Ali and Julia. Much appreciated. Here we go. Maybe just crabby on a Tuesday. Is it Tuesday? It is, right? We had yesterday off. And then you have Friday off. Why would you be crabby today? Good Lord. All right. And by Lord, just mean Lord of the Manor, not in any particular, belief system or anything like that. Don't want to get anyone all upset in the world that we live in right now. What did you say? Okay. Hey. I think we should be able to get this pretty quick then. 1 point. 2 points. Okay, this is what we're talking about, points values on this this kind of question. Now, if I made this 4 points, this would be worth 2, because this is the tough part. This is the one that really is, really a challenge. First of all, 2, I mean, come on, we go from 2 to -2. That's the idea of amplitude, half of the y-axis. It's upside down, and it's a sine. So we got all those things happening right there. So then the thing that I just showed you off to the side, the period is the x-axis distance that this sine curve is completed. That is one sine curve. Uh-oh. I don't know what that is. Oh, I accidentally hit the keyboard. Now I get a random C in here. That's going to drive me nuts. My ADD is going to kick in, and that's going to drive me crazy. Anyway, so then the period is pi. So let's use that thing that I showed you over there. B is equal to whatever 2 pi over the period is. Okay. So now I can see from my other questions, if I had to graph this, I'd have to go 2 pi over 2, which is pi, and then I'd have to complete a sine curve at pi. Got it. It all makes sense. Okay, next one. I got 3 minutes. Please, in the chat, do a little bit better. Let's have a little, positivity here. What do I see here? So do I see a sine or do I see a cosine, depending on how it starts? And do I see everything that I need to see? kind of stuff that you have to kind of figure out. Think as you're writing this down, 5, 4, 3, 2, 1, go ahead and put the answer whenever you want. I think we also should see that we already have a 3 for an amplitude value. Nobody? It's so awkward. It is a cosine. Is it a full cosine? Or how much of a cosine do I see? See the time frame there. Is that a full cosine kid? Is that what we saw for a cosine kid, just that? Is that what we saw in the movie? Nice. Anyone that's seen the Karate Kid or Cobra Kai knows that the full crane is, we got to have that other arm up, man. Got to be like this. Okay, not like this or whatever. So what is the period? Real fast, put that in the chat, and then we can move on. What is the period? Half of the cosine kid's graph. So what is the period for this? Wish I had some music to drown out the silence. Really? No one's going to answer? So this is half of the graph, and that's what I see. So what would be over here if this is halfway? Nope, still don't have it. Oh, troubles of teaching high school. Nobody's going to answer. So this is half the distance, x-axis from here to here. So how much more would I be to get here? What would this numerical value be on the x-axis? Oh man, we're going to use up all our time. Hey-oh! We got it. All right, I think a lot of people knew that. I just think we're on strike. 4 pi. So b equals 2 pi over 4 pi, which is a half. It's not upside down, so it is 3 cosine half of x. Hey, another meaning of this half. Notice this is half of a cosine curve up to 2 pi. Look at the next one. No time for this, as we're, I don't think anyone's going to answer anyway. So we'll just move on. Oh, I'm seeming to like a equals 3. I want to give you a second to think about what you see here. Last hour did have some problems with this, seeing what they thought they saw. But this starts all the way down here at the low value, then to the high value, then back to the low value. That is a cosine kid upside down. Okay, so that's what you kind of have to see and chop it. This is a period. So this is the end of one cycle. So the period is pi over 2. The b value is, shoot, I had a number in my head and it just came out of my brain too early. 4. All right, dividing by pi over 2 is multiplying by 2 over pi. Pi is canceling, you end up with 4 there. So it's upside down. And then one more thing to show you before you jettison out of here. Notice 1, 2, 3, 4 cosine kids up to 2 pi. That's another meaning of that 4 in that little position right there. When you get cosine of 4x, it smushes this down to get one cycle 1/4 of what the parent is. Hence, there'll be 4 cosine kids up to 2 pi compared to the parent function. Okay, so another meaning of that you could kind of go back and double check that you did it right. Just like this one is half of a cosine curve up to 2 pi. Half. That's what that does there. Stretches it out the other way. Okay, see ya. Have a good day. Get tomorrow, half of you.